Hello everyone and welcome to the video for section 7.5 on polar coordinates and graphs. Our skill objectives for this video are: 1, we want to plot points in the polar coordinate system. Number 2, convert between rectangular and polar coordinates. Number 3, convert between rectangular and polar equations. And number 4, graph polar equations. So we'll do all 4 of these in this video. The conceptual objectives for this one are: 1, relate the rectangular coordinate system to the polar coordinate system. Number 2, classify common shapes that arise from plotting certain types of polar equations. Let's start out by going through some of the basics on the graphs here. This is a graph I found online. It's good enough for what we want to do in terms of the graphs here, in terms of plotting the points. The grid I found did have the degree measures labeled, and I have added the radian measure because you'll have to deal with both. And what we have over here are a set of points that we're going to graph. Now, when you graph something on a polar grid, like we see here, you have this center point right there, what we normally think of as the origin. That is what's called the pole. And now when you graph these things, what you really have to do is you have to imagine yourself on the pole staring off down towards that 0 degree. And when I graph these, when you look at the points, you're going to see the points in polar coordinates are always going to be r theta. R deals with a radius, and the radius length is really each one of these circles. Like if I let each one of these circles represent one unit, this would be 1, that would be 2, 3, 4, 5, 6, 7, 8, 9, 10. I think there's supposed to be 10, so. Yep, 10. All right, so you have those. Now, what happens on here? We have an angle measure. So in this first one, I want to graph the point 4 and 60 degrees. So what I have to do is imagine myself on the pole. I am staring off in this direction. And now what I'm going to do is I'm going to rotate 60 degrees. So now I'm at the pole. I'm staring right down here towards that 60. And now with the 4, what I'm going to do is I am going to move 4 circles out. So 1, 2, 3, 4. And I will go through it there, and I will put a dot. And that is point 1, which is the point 4, 60 degrees. Now, I can do this again with radians as well. 7 pi over 6. So I'm going to start out here at the pole, looking down here. And I'm going to rotate 7 pi over 6 radians. So I'm right here, and now I'm looking right down at this on this one. So I'm at the pole, I'm staring down here. And now I need to go, I have the point 7. Well, if I'm staring here, I can just go 1, 2, 3, 4, 5, 6, 7, and I can put a dot there at that point, and that is point 2. That's the point 7 pi over 6. Now another one we have here, this is something different. Number 3, it's -5, 300 degrees. So I start here at the pole, and I'm going to rotate 300 degrees. So I'm looking here, I'm going to rotate around 300 degrees, and now I'm here staring down this line. But now because I'm -5, what I'm going to do, this is why I like to think of myself standing here, looking down here. -5 means I'm going to go backwards 5. And so when I go backwards 5, I'm going to have a dot right here. And that will be point 3. Please keep in mind that the angle measures themselves can also be negative. And so when I go -7 pi over 6, so I'm staring at the pole here. Now that's going to be 7 pi over 6 radians in the clockwise direction. So remember this, if I start here, when I go clockwise, there's -1 pi over 6, -2 pi over 6, -3 pi over 6, -4 pi over 6, -5 pi over 6, -6 pi over 6, -7 pi over 6. So I'm here, and I'm staring down here, and I want -3. So again, -3 means if I'm staring in one direction, I'm moving backwards from there. And so I would have a dot right there. That would be 0.4. Now, one of the things you have to also keep in mind here is that, and what's unique about these polar coordinates is that they do not have a unique name. Number 4 is -3, -7 pi over 6. It would also be +3, 11 pi over 6, or +3, -pi over 6. It could also be +3, 23 pi over 6, going by multiple times. Same thing with the negative. It could be -3, +5 pi over 6. Okay, so you can do that as well. So there's multiple representations for each one of these points. Now, one of the things you're going to be asked to do is convert between polar and rectangular coordinates. To go from polar to rectangular, what I'm going to do, that's where I'm going to go from where I'm given r theta, I'm going to convert to x and y. Really all I have to do is, I know x is going to be equal to r cosine theta and y equals r sine theta. When I'm going from rectangular to polar, that means I have x, y, I want to go to r theta. I know r equals the square root of x squared plus y squared, or I could say r squared equals x squared plus y squared. And I know the tangent of theta is going to be y over x. That's something we've been using since we first started working with the trig back in chapter 4. And from that, because tangent of theta is y over x, I know theta is going to be the inverse tangent of y over x. And this is all provided, again, that x does not equal 0. Let's take a look at a problem here. I want to go through, I have polar coordinates to rectangular. So I have the point in polar coordinates of 7, 132 degrees. I want to find the rectangular coordinates for that. And so I know x equals r times the cosine of theta. R is 7, theta is 132. So x is going to be 7 times the cosine of 132 degrees, which will come out to be -4.684 when I round that to 3 decimal places. I can find y. Y is 7 times the sine of 132 degrees, which will be 5.202 when I round that to 3 decimal places. And so the point 7, 132 degrees in rectangular coordinates is the point -4.684, comma 5.202. What I would like you to do right now is pause the video, and I'd like you to identify the rectangular coordinates for this point at 330 degrees. Welcome back. On this one, I've now done the work. You can see it on there. You should have come up with the point 3 square root of 3 over 2 and 3/2. Now, a lot of you probably went and used your calculator, and if you did, you came up with 2.598 and 1.5. These are ones that, 330 degrees does happen to be an angle that's on the unit circle, and so being able to do that exactly can also be helpful, because 330 degrees, you can identify the exact value of the sine and cosine there. So for my purposes, for our purposes, I will sit there. If you can remember the exact value, great. If not, you can go and give me the decimal rounded to 3 decimal places. Now let's take a look at a couple examples where I'm going to go from rectangular to polar. Now this does present a little bit of a challenge. Polar to rectangular, no big deal. You just plug it into those 2 formulas, it will work out. What the problem that you have with going from rectangular to polar, remember that theta is the inverse tangent of y over x. Well, inverse tangent is going to give us an angle between -pi over 2 and pi over 2, or -90 and 90 degrees, which means that we have an angle that's in quadrant 1 or quadrant 4. What you have to be aware of is if the point you're given is in a quadrant other than 1 or 4, if it's in 2 or 3, then the angle that you get, you get one of 2 options. Option 1 is realize that r could be negative, and you could use the angle that comes out. Or you could go through and just add 180 degrees or pi to the angle that comes out and of your inverse tangent, and that will give you the correct angle with a positive r. Let's take a look at a problem here. In the first one, I have the point 3, 4. 3, 4 both x and y are positive, so we're in quadrant 1. So I don't have any issue in terms of theta. I go through, I remember that r is the square root of x squared plus y squared. And so I plug 3 in for x, 4 in for y. I get 3 squared plus 4 squared, which is 9 plus 16. That does equal 25, so r equals the square root of 25, which is 5. So I get r equals 5. I also know that the theta is going to be the inverse tangent of 4 over 3, y over x. And when I put that into my calculator, I got that theta was about equal to 53.130. Now, since our point, the point 34, that point is in quadrant 1, I don't have anything to worry about, and I know that the polar point where I used this r and that theta is going to be a polar point for the point 34. So I know 34 is in polar coordinates 5, about 53.130 degrees. Let's take a look at the next one. Now you'll notice I'm looking at negative 12, 5. Well, that's in quadrant 2. Quadrant 2 is not a quadrant that the inverse tangent will give us an angle in. So what happens here? I can find r. I put negative 12 in for x. I put 5 in for y. So I got negative 12 squared plus 5 squared. Now remember, negative 12 squared is going to be a positive 144 plus 25. That's the square root of 169, which equals 13. The inverse tangent of y over x is the inverse tangent of negative 5 over 12. When I put that into my calculator, I get negative 22.620 degrees, which is an angle whose terminal side is in the fourth quadrant. To go through on that, what I'm going to have to do is I can add 180 to that. When I add 180, I get 157.380 degrees. And so now I have two options for the polar coordinates for the point negative 12, 5. The first one I can use is 13 and the 157.380 degrees, and that's fine. Another one I could use would be negative 13 and a negative 22.620 degrees. Now, if they wanted a positive angle measure on that, I would get, this would also be the same as negative 13 and 337.38 degrees. So all of these answers on this particular problem would be correct answers for the polar when I convert this to polar coordinates. Now the reason you have, I have so many different ones is because the angle that I started out with here, this is an angle that is not on the in quadrant 2 where this point is. So when I added the 180, I got this. That's an angle that's in quadrant 2, so I can use that with the positive 13 to give me a polar point for negative 12, 5. These ones, though, again, because we do have the multiple representation, these would also be correct answers as well. Now let's look at when we convert equations. In this case, we have a rectangular equation. We want to convert it to a polar. Well, again, remember, x equals r cosine theta, y equals r sine theta, x squared plus y squared is r squared, and the tangent of theta is y over x. That should be an x on that one. So we'll make that into an x. So the first example that we have on this one is 3x minus y equals 2. And I want to convert that into a polar equation. Well, what I do is I know that x is r cosine theta and y is r sine theta, so I just replace the x and y with r cosine theta and r sine theta respectively. I go through, pulled out the common factor of r, so I have r times 3 cosine theta minus sine theta equals 2. And then dividing by this quantity, I get r equals 2 divided by 3 cosine theta minus sine theta. And that would be our polar coordinates. In the next one here, I have x squared plus y squared minus 4x plus 2y equals 0. Well, I know x squared plus y squared, that's equal to r squared. Minus 4r cosine theta plus 2r sine theta equals 0. Now going through and getting everything over to the other side, I get that r squared equals 4r cosine theta. Oh, that should be minus 2r sine theta. That should be a minus there. And so what happens on that one is I can go through and get that. Remember, our polar coordinates are always with r equal, the expression involving theta. And literally, I can now divide through by r, and I get r equals 4 cosine theta minus 2 sine theta. And that now would be the equation, the polar equation for what we see in number 2. The next one we have is where I want to convert from polar to rectangular. So in this case, what I have is r squared cosine squared theta minus 2r sine theta equals 8. Well, this piece right there, that is just r times the cosine of theta, that thing squared, minus 2r sine theta equal to 8. And now I know r cosine theta equals x, so I replace that. So I now have x squared minus 2, r sine theta is y, so I have x squared minus 2y equals 8. And now it's really just a matter of going through and solving this for y. So I subtracted the x squared, and now I'm going to divide everything by negative 2. And so I get y equals x squared over 2 minus 4. And that would now be the rectangular equation for that polar equation that we were given. Now it's important as you go that when you're going to convert from polar to rectangular that you want to be able to go and get it so that you can rewrite it so that you see what you can replace an r cosine theta with x and an r sine theta with y. Now what we're going to see here is graphing polar equations. And the polar equation that we have in this case is the r equals 3 plus 3 cosine theta. Now I've gone through and identified some values so far. On here we got when theta equals 0, r is 6. When theta is 30, r is 5.6. When theta is 45, r is about 5.1. When theta equals 60, it's about 4.5. And when theta is 90, it's about equal to 3. Now what I'm going to do is I'm going to go through and plot those points. And you should go through and on the screen identify where you think those points are. And then I'm going to pause the video, I'm going to put those on, and then when I start back up, you'll see the graph there. So I'll be back in a couple of seconds. All right, now what you see in those red dots would be about the location for these points right here. And now the graph of this polar equation is really just going to be found by connecting these dots. So I'm going to come along here, I'll go through that one here, and I'll be to there. So that's roughly that portion of that polar graph. Now what I'm going to do is I'm going to pause the video again, and we're going to plot these next 4. So at 120, we're going to be at 1.5. At 135, we'll be at 0.9. 150, about 0.4. And finally, 180, we'll be back at 0. So in a few, I'm going to again pause the video, and then when I come back, you're going to see this next portion of the graph, at least the dots for that next portion. All right, I'm back, and now you can again see these dots right here. That first one there is about at 1.5. Then this is at about 0.9. Then as I work my way in, the next one in is going to be at 0.4 and then 0. And again, I go and connect these dots, and what I'm going to get is something that kind of goes like that. Okay, and now one of the things that happens on here, we're going to go through and do the next set as well. But once you do this, you will start noticing a pattern. For example, at 210, I'm going to be back at 0.4. At 225, I'm going to be at 0.9. At 240, I'm going to be at 1.5. And then at 270, I'm going to be back at 3. And so I'm going to plot those points, and we can see what that looks like. So now I've plotted those points for the 210 through 270. You can kind of see it's going to come out like this. And when we do the remaining ones, we're at 3. The next one at 300 300 degrees, we're going to be at 4.5. So that's going to end up being, that's 4.5 right around here. Now the next one at 315 is going to be a 5.1, so just a little bit past there, right there, about. And then at 330, it's going to be a 5.6, so closer to here. And then when we get to 2 pi, we're going to be back at 0. So graphically, what I'm going to see then, if I connect all those dots, is going to be this. And what we have here is what's called a cardioid. You can kind of see it does have a little bit of a heart shape to it. Now there are other types of graphs that you can find. You can see the different types of graphs. You can find them on page 751 to 752, the different types that you can see. And a lot of these can also be done on your calculator. To graph them on your calculator, you're going to want to put your calculator into, into polar mode. So if you press your mode button, remember how we changed it from function mode to parametric. Now you're just going to go to POL. And when you do that, that's going to change all your other screens. When you press the Y equals, you're going to see R equals. The window, when you're in polar mode, instead of seeing T min, T max, you're going to see theta min, theta max. And you can see those values there, and you're going to set it up, and then you can go and graph it. Now you're still going to be dealing with, your calculator ends up graphing these things. Even though you are in polar mode, it does go through to graph it. It does convert each point into rectangular coordinates. So that's why when you look even in polar mode, you're going to see in the window, you'll see the X and the Y in terms of the axes. But so make those changes, put that into polar mode, and then you can go through and try graphing some of these as well. Remember, you do have to get it written as R equals. So do whatever it takes to solve each one for R, and then you'll be able to see the graph. So with that, this does conclude this last video on polar equations. It is a little bit longer than the last one. Sorry about that. But with that, I will see you at our next class.